Welcome you all to this section of worked out problems on projection of lines. So hope you all have gone through the previous sections of the different construction techniques used in projection of lines, like line rotation method and plane rotation method. So here we are actually looking at a couple of problems where we apply these techniques and try to solve typical university questions and questions which come in exams. So we are trying to solve this in that concept. So the problem types normally depend on the type of data which is given to solve the problem. So one thing is in common in projection of lines problems is that you require at least 5 different data to do a problem, and this can come in different flavors. That is, one is you will be given the true length, the position of both endpoints with respect to VP and HP. So that itself makes it a 5 different data. That is, true length is 1 and position of each endpoint, so that makes it 4. That is, every endpoint will have a distance from VP and HP. So since we have 2 endpoints, so that together makes it 4. So 4 plus the length of the line, so that together makes it 5. The second type would be true length, position of one of the endpoints, so that makes it 1 plus 2, 3, and the inclination, that makes it 4, and the length of one of the projections, that makes it 5. And yet another type would be where the position of both the endpoints, that makes it 4, and the distance between the projectors, that makes it 5. So this is a typical type of questions which you see in exams. And in fact, there are other combinations where you can even have the true length and both the inclinations and position from one of the points. The only idea you should have in mind is where I should start. So probably this set of worked out problems will give you an idea how we should go about solving a problem. Knowing the theory of projection of lines is a different aspect compared to how you actually solve a problem. And this is where many people find it difficult, where I should start really. So probably this particular set of problems would help you in cracking this issue. So let's start with problem 1, where it says that the line AB is 75 mm long and its end is 20 mm in front of VP and 25 mm above HP. So this basically is nothing but the position of points which we mentioned before. And the NB is 65 mm in front of VP and 60 mm above HP. So one thing we could think in this stage is where exactly is the line lying with respect to the 4 quadrants. So here, since it is both the ends are above HP and in front of VP, which this should naturally be in the first quadrant. And the question is, you need to find the inclinations and draw the projections. So let's start. Again, before starting, one more thing I would like to remind you is that the most widely used golden rule, if you refer back to the construction techniques, I've mentioned some golden rules. So the most widely used rule is that if a line is parallel to one of the planes, the other view, that is the view on which it is inclined to, will be a horizontal line. So we'll be using this very frequently, especially in the line rotation technique, where normally the way is you start with the true length. Provided the true length is given, you start drawing the true length, then you project it down to the next view, and so that it becomes a horizontal line. So here what you're trying to do here is you assume that the line is initially made parallel to one of the planes, and so that the other view becomes horizontal or parallel to XY. And then from there the next technique would be to rotate that view and while rotating, you make sure that the rotated part, rotated line the end of that line will be lying on the locus of the other endpoint. And then you proceed like that. So let's directly go into the problem now. So we start with the XY line. Now we start drawing the positions of point A, which is A dash and A, which are nothing but the projectors on VP and HP. And now regarding the next set of positions, we draw only the locuses, because we do not know exactly at what distance. So now from A dash, we draw at 75 mm, we draw B dash on the locus. Now we join A dash and B dash. Which is actually representing the true length, the projection of the true length on VP. Now we project this A dash B dash down. So remember the golden rule I was mentioning. Now this line is parallel to VP and inclined to HP alone. So naturally AB should be parallel to XY. So the next step would be to rotate this AB so that the other end, that is B, should cut the locus MM. So that is AB1, which is actually the projection, and AB1 dash will be the front view. So what we have done here, we have started by positioning points A dash and A from XY based on the distances given as 25 and 20. Then we proceeded by taking 75 mm, which is a true length, and cutting that arc on the locus MM dash, M dash, M dash. And this M dash, M dash and MM are nothing but the locus of the other endpoint, which is again derived from the question, which says that the other endpoint is 55 mm above and 65 mm in front of VP, 55 mm above HP and 65 mm in front of VP. So based on that, we have drawn the projectors. So once you have drawn A dash, B dash, that is not the final projection. That's only the intermediate stage where we assume that the true length is parallel to VP and inclined to HP. So from there, naturally we project it down and we have drawn AB. And now the next thing what we are doing is we are rotating AB with AS, the hinging point. So here two things we have to consider. One is that the length AB is not going to change. The reason being the inclination with HP is not at all changing. We are only inclining the line or tilting the line with respect to VP, keeping the tilt or inclination with HP intact. So that's the reason why we are able to rotate that arc AB directly so that it cuts the locus MM. Again, why we are cutting locus MM? But since we know that the line, the endpoint of the line will fall on that locus, anywhere on that locus. So once you get that, so AB1 is the actual true projection of the inclined line, true projection of the inclined line on HP. Now we also need to get another view, is a front view of the inclined line. So that is, which is nothing but A dash B1 dash. Now that we have simply projecting the position or point B1 directly onto the locus M dash M dash, join A dash and B1 dash. So we have got the projections. Now proceeding further, we need to find the inclination. So at A, we draw a horizontal line, and in fact that horizontal line, it cuts with the end B1 dash, the arc drawn from end B1 dash, and if you project it back, you also get the other true length. To explain this step once again, once you have drawn A dash B1 dash, the next step what we did is we rotate A dash B1 dash with AS center and made it parallel to XY line. So what we are trying to do here is the reverse of what we have done before. That is, initially we have drawn A dash B dash, assuming that the line is parallel to VP and inclined only to HP, projected it down to get AB, which we know is horizontal. But here what we are doing is the reverse. We made A dash B1 dash rotate and made it parallel to XY line. So now the moment we project it to the top view, what we are going to get is a true length in the top view, which really means that this true length will be the case where the line is parallel to HP and inclined to VP. So that's what we are doing when we project A dash B2 dash directly to the top view and get A B2. So now we can actually start drawing the inclinations, which are 24 degrees and 32 degrees respectively. Let's go to the problem 2, where it is very similar to problem 1. Here only things, the length of the line is changed to 65 mm, and similarly all the endpoint positions with XY are given. See, one thing I'd like to highlight here is in some questions, instead of giving the data like as in front of VP and above HP, it might be given as the point is above XY line and below XY line. So this also has to be seen in the similar sense. So if you say that point, the front view is above XY, you can always say that it is either in the first quadrant or in the second quadrant. So it depends on the moment you get the position of the with respect to the other plane, you can immediately decide in which quadrant this point is going to lie. If you know that the point is above XY line, that is the front view is above XY line and top view is below XY line, naturally means it is a first quadrant. But if it is the reverse, that is the front view is below XY and the top view is above XY, it is quite clear that it is going to be the third quadrant. So these are some things which you have to keep in mind while solving problems. These are some hints which could help you to immediately visualize how the line is lying in a 3D space.